thank you for joining us today. This is the second workshop in our series of 4 that we're running through the month of June. If you were here last week, we looked at good practice and particularly using the network review feature in Paramics Discovery. We recorded that session in case you missed it, and we're going to be posting that on our YouTube channel and support center so you can catch up on that in your own time. So let me introduce myself in case you don't know me. My name is Malcolm Calvert. I'm the director of Paramics Microsimulation based in Edinburgh. Paramics is part of SYSTRA Ltd. I'm delighted to be joined today by Callum Guild, who's an associate transport planner at SYSTRA. Callum and I go back a long way in our working lives. We both worked for SIS, and Callum, maybe 20 years. Callum, is that fair?
Yeah, I think that's fair enough. Yeah, fair
I think I'm on about 17, maybe you're on about 20, but Callum's a very, very experienced Paramics user. He's been based in Perth for a large part of his career, and by nature of his location, he's worked on several models in Scotland, particularly the sort of northeast areas of Scotland that he's going to be showing us a model of Aberdeen today. So let me just say a couple of things about the session, how it's going to work. It'll last for about an hour. Callum's going to talk for 45 minutes or so, and then we'll have time, lots of time at the end for questions and answers. There's a chat function on Livestorm, so please chat through the session. Feel free to leave comments or your own thoughts and reflections. We've got a lot of experienced Paramics users on the call, so it'd be great to hear from you. There's also a questions column on the on Livestorm as well, so please feel free to ask questions. I'll keep an eye on those, and it might be appropriate to interrupt Callum, just ask him in the moment, or we might store some questions back for the end. But please just ask. There's absolutely no stupid questions at all, so please, whatever comes to mind, please ask, and we can discuss it. And we're also really happy to bring other people onto the audio and video. So if you would like to share or ask a question on the video or audio, or share a comment or your own experience, then please let us know, and particularly towards the end of the session we'll have time to do that. Okay, I don't think I need to say anything else, so I will hand over to Callum, who's going to talk to us about low emission zones in Aberdeen using Paramics Discovery.
Great, thanks for that, Malcolm. I'll just set up my PowerPoint, bear with me. Swap our display settings. There we go. Just move that over there. So the session today is more of a case study as opposed to lots of individual elements about using Paramics, and it's to talk about, we've been working a couple of years now on developing a model and assessing a low emission zone in Aberdeen. So what I'm going to talk about today is a little bit of background on low emission zones, not too much, just to give you an overview if you don't know about them already, and also to kind of discuss how we used Paramics to develop and sift low emission zone options and really come up with our preferred scheme, which is where we're currently at just now. We do have a preferred scheme, which is going to committee this month. So that's the kind of shape of this presentation. So just to start at the outset, a very broad overview of what are low emission zones, or I'll refer to them as LEZs for short. They are a Scottish Government programme. It came in 2017, and very similar to clean air zones that are in place in England. It's essentially the same scheme with a different name. And what low emission zones are really is you set a zone and it restricts access within that zone for the most polluting vehicles, so that they can't come in that zone without paying a penalty. And ultimately that's to provide improved air quality within that zone. So there, as I say, there is a penalty for older vehicles, and I'll detail what those vehicles actually are. What is classed as a compliant vehicle and a non-compliant vehicle. And as I said there on the screen, there's a penalty charge if you're a non-compliant vehicle. I think currently the view is similar to parking charges of £60 reducing to £30 if you pay it within 2 weeks. That sort of pricing, it's a bit similar to congestion charging. So that's what they are. There is a lot more information on low emission zones on that website that's detailed here. lowemissionzone.scot gives you a tremendous amount of background information as to what is involved and what low emission zones are. As I say, my focus here is really to show how we developed the scheme for Aberdeen and how we used Paramics to develop that scheme. I suppose the next question is why? Because air pollution in Scotland is generally not too bad. It's quite good on the whole, but there are hotspots, predominantly within the larger city centres and the built-up environments. And road transport is a major cause of air pollution, and it's really quite a hot topic at the moment in terms of people's health and the connection between air pollution and illness and lung illness and so forth. So low emission zones themselves, as well as reducing the pollution, obviously, within the zone, they do help to protect public health. That's a key element here. But there's also other elements as well. There's economic elements, when you think about placemaking for the city centres, more attractive place to be and visit if there's not high pollutant vehicles in the air, or the emissions from the vehicles in the air. And they also encourage more use of public transport and active travel, walking and cycling, etc. Where we are currently is that the Scottish Government have announced that there's low emission zones to be introduced in 4 cities in Scotland: Aberdeen, Dundee, Edinburgh and Glasgow. The regulations and guidance came out in 2019 in draft form, but it's yet to be published later this year in terms of the signing and regulations related to all that. But LEZs are within the Scotland Transport Act in 2019. The key point on this slide is really when I was mentioning what is deemed a compliant vehicle, what is a non-compliant vehicle. Basically, for buses, coaches and HGVs, we're talking about a Euro 6 vehicle, which is about 2013. So Euro 6 from 2013 onwards are deemed compliant vehicles. Unless, of course, particularly for buses, they are retrofitted. So older buses can be retrofitted to become compliant vehicles, and there's funding available from the Scottish Government to help the retrofitting of older buses. For cars and smaller vehicles, minibuses, large vans, it's a Euro 6 classification, so that's about from 2015, but that's for diesel engines. And for petrol engines, it's a much older vehicle is compliant. It's a Euro 4 from 2006. And there's a Euro 3 for motorcycles and mopeds. So all vehicles that are at that emission standard and beyond are classed as compliant. All the vehicles that are predating those classifications in years are classed as a non-compliant vehicle. They are the high polluting vehicles, which the LEZ will be effectively removing from the zone that you've created. The LEZs, as it says there, are due to be implemented by or in 2022, and there's potentially a 2-year grace period within that as well. So we're talking about 2024 when all the schemes in the 4 cities are up and running. Now, there's a lot of words on here. I'm not planning on reading through it. It's really the statement of the objectives for Aberdeen, and each city had slightly different objectives, but effectively the key objective is quite obvious, is to reduce the harmful emissions from transport to meet the air quality objectives. But what's quite important is there are supplementary objectives for Aberdeen, that a low emission zone has to support other local and regional transport strategies. So it's part of a package of measures to deliver your future city centre. It's not a standalone scheme. So I'll come on to the other elements that form what our LEZ package of measures were for Aberdeen, but it wasn't just a low emission zone on its own. So as I say, it's a package of measures to meet the long-term objectives for Aberdeen City Centre. Now, there's two key ongoing committed proposals for Aberdeen, one being the City Centre Master Plan, which is a 25-year programme started 5 years ago. So 20 years to go in this programme of effectively changing the traffic operation within Aberdeen City Centre to a more sustainable environment, whether that be pedestrianisation, bus only, bus and taxi only, etc. There's a whole series of measures proposed for Aberdeen over the next 20 years that clearly we'll have to take account of these when we're looking at a low emission zone. The other element that we had to take account of when looking at a low emission zone was a new road network hierarchy for Aberdeen, which was developed following the opening of the Aberdeen bypass, the AWPR, which opened in early 2019. So obviously that becomes the trunk road. There's detrunking of roads within Aberdeen, and it was an opportunity to really reclassify all the roads through Aberdeen and effectively declassify or detrunk the roads that go right through the heart of Aberdeen. So what we have to do as part of the low emission zone is take account of the fact when we do displace non-compliant traffic from the city centre, then we're not putting that traffic on roads that's not appropriate, minor roads, local routes. So that is another layer of cognizance that we had to take when developing a low emission zone. So the overall process for developing a low emission zone, there's three elements here, but the first element is the overall framework. There's the National Low Emissions Framework, which is a guidance. It's an evidence-based appraisal process that's recently been produced. And it's really to help the local authorities consider what transport actions they can do to improve the air quality, the local air quality, when transport is considered a key factor in that. And that link there is more information, if you want, on the low emission framework. Underneath the umbrella of the low emission framework, there's two other processes going on. One is the focus of what we were involved in was the traffic modelling of options using Paramics Discovery. So what we did with Paramics was look at the operational assessment of different boundary options for a low emission zone. We used a model to look at the impact of displaced traffic. When I talk about displaced traffic, that's the displacement of non-compliant traffic from the zone. We're able to then identify where the traffic congestion issues might develop by that traffic displacement and develop mitigation or demand management measures to deal with that displacement. What we're also able to do is identify the impact of the low emission zone on specific areas of interest, likely air quality improvements where there's an air quality concern area. And I'll come on to this in a later slide. Where there's areas of basically high emissions, we can look at the traffic model and see when we implement the low emission zone, do the flows go up, do the flows go down, what happens at those locations. The third element to the whole process is where SEPA came into the study and they are undertaking the air quality modelling. So that utilises outputs from the traffic modelling to undertake a detailed air quality assessment on the, in this case, it was on the final scheme. So in Aberdeen, there are approximately 70 sites where there's passive diffusion tubes that pick up the air quality throughout the city centre. I think there's continuous monitoring at about 6 sites. But this image here shows there's 14 sites around Aberdeen City Centre where in 2019 there was nitrogen dioxide, which is the key component of emissions from vehicles. There was 14 sites that were areas of concern, basically. If we look at the key here, the amber colour, the orange colour, is where the nitrogen dioxide levels were between 36 and 40, that's micrograms per cubic metre. And the red areas are where those levels were over 40 micrograms per cubic metre. Now, the threshold for what's deemed compliant vehicle or compliant or non-compliant, or what's deemed acceptable levels of emissions, I should say, is at 40. So the amber ones are where the exceedances are up, or the emissions are approaching the exceedance, and the red areas are where in 2019 exceedances, the emissions were above the acceptable level. So this is important data as a starting point. As I said before, in order to assess the low emission zone or the zone options and look at different options for a low emission zone, we developed a Paramics Discovery model in 2019. Luckily, we got in before COVID hit, which was useful. And this was developed from an extensive traffic survey programme, including, junction turn counts, ATCs. We used INRIX data for journey times. Critically, though, we gathered ANPR data to do ANPR matching for travel patterns. But of course, ANPR data, once you have the registration number plates, they can be cross-referenced with the DVLA to get a flavour or the detail of the engine types that are routing through the network. From that base model, we therefore developed a future year reference case model, which was 2024, and we included committed developments, committed infrastructure known for that time. We also utilised input from the higher level strategic model, the ASAM model, which covers the whole of the northeast of Scotland, to apply the impact of development and infrastructure out with the model area itself. So there was input from the higher tier strategic model to develop our future year reference case model. It's really critical when it comes to modelling a low emission zone that there's a framework set out for how you're going to model it and what assumptions you make before you start. There was consistency group meetings across the 4 cities at a wider level in terms of the overall low emission zones. But equally, there was modelling group meetings for the 4 cities in terms of what assumptions we are making within our traffic models. How do we model a low emission zone? Now, generally, the assumptions made were consistent across each city, but there are some local differences, primarily due to geometry and the local network layout. For example, in the Dundee low emission zone, that zone is within an inner ring road through Dundee, and the way that inner ring road operates is there is no through traffic through the inner ring road. You have to go in and come out. So the Dundee low emission zone doesn't really have to consider the impact of traffic that's routing right through the low emission zone. Whereas in the likes of Aberdeen, it's absolutely a critical element. At the moment, Union Street in Aberdeen is almost used as a trunk road through the middle of Aberdeen. So it's effectively the opposite of Dundee. So there are subtle differences between them all. There's a couple of things I just wanted to highlight. Just click on this Excel sheet here. I'll come on to the model itself shortly. It's just a couple of points I wanted to make about the assumptions that we apply in the model. So we have the 4 cities here. So we kept cognizance of what was happening in all the other cities. The fleet composition in terms of what's compliant and non-compliant, that has to be applied within your traffic model. For Aberdeen, that was derived by SEPA with the ANPR data and background data, and I'll come on to a slide about that in a minute. We also took account of what the fleet compliance was in our opening year. So we have a fleet compliance level in 2019. What would that compliance level be in 2024 if people keep improving their vehicles, and so the emission levels go down? So we took account of that as well. We didn't include any mode shift assumptions in terms of moving from traffic to bicycles. This wasn't across any of the other models. It's trying to keep as many things consistent as possible as part of the assessment. The key element I wanted to really focus on is the 2 travel types through a low emission zone. One is traffic that routes through the low emission zone. Effectively, it starts out with the LEZ and ends out with the LEZ. Now, within that, our assumption is that all buses were compliant because they were either new buses or retrofitted. That is part of the condition of the low emission zone. And same with taxis. All taxis were assumed to be compliant. I think if you had a taxi that wasn't compliant, you wouldn't get much business from Aberdeen City Centre. So there was an assumption that all taxi drivers would ensure that their vehicles were compliant. All other vehicle types, the cars, HGVs, LGVs and cars, all vehicles that are non-compliant would effectively divert around the low emission zone. And this is where the Paramics model comes into its own, is that non-compliant vehicles will still make their route, but they will divert around the low emission zone itself. The other element that I hadn't considered really until we got right into it was for vehicles that effectively originate or destinate within the LEZ itself. So if there's a trip that comes into the city centre or leaves the city centre, what happens? What do you do to your trip matrices if suddenly there's a low emission zone and that is a non-compliant vehicle? I'll come back to cars in a minute. Again, taxis were assumed to be compliant, and LGVs and HGVs were also assumed to be compliant. The thought process being that HGVs would know that if their destination was within a city centre, then they would have to have a compliant vehicle in order to get to that city centre as part of a delivery. And again, buses were assumed to all be compliant. In terms of cars, there was different assumptions across the 4 cities. Different cities took different views. In Aberdeen, we looked at a mixture of some cars would automatically be compliant, but some cars that were parking in off-street car parks, there would be a reallocation of destination. And again, I've got a slide relating to that that'll explain that more clearly. So there's a whole series of things that we need to consider before we even model anything in terms of what is the assumption here of what's going to happen with our low emission zone. How do we model this? Going back one stage to the compliant proportions and non-compliant proportions, SEPA were able to provide from their emissions factor toolkit, they have software to derive the future proportion of compliant and non-compliant vehicles. But this is at a national level. So if I can focus here on, if you look at the cars proportions in 2019, we can see that 75% of cars were compliant, 25% obviously were not compliant. The prediction through the EFT software suggested that by 2024, this had gone up by approximately 16% of compliant vehicles, and the level of non-compliant vehicles was down to 8%. So it's a 16% shift in cars becoming compliant new cars and people getting rid of old diesel cars, or in fact, people just not buying new diesel cars either, or older diesel cars, I should say. What we did in terms of Aberdeen was we knew what the proportions were in Aberdeen from the ANPR data. So we had local data for Aberdeen. So instead of 75% compliant, in Aberdeen it was 70% compliant cars. So we applied that growth to a local number. So effectively by 2024, instead of 70% cars compliant, we've got 86% compliant. And the same goes for LGVs and HGVs. There's proportions for those vehicle types as well. So what do we do in terms of the demands within the model in order to model a low emission zone? What this image shows is how the base model, the Paramics base model, was constructed. Quite a standard approach of 3 peaks, AM peak, interpeak, and PM peak, effectively a 12-hour period. Within that, we had 2 demand sets. So we had a lights and a heavies demand set, all very standard approach to developing a model. Within those, for example, we've got the cars, LGVs and taxis split based on the traffic surveys that were undertaken. So we've got a split of vehicles within these matrix levels. And again, within the heavies, there's a vehicle split. In order to model a low emission zone, so if I just take the slice of the AM peak, if you like, so this is the AM peak slice that we had before. What we had to do was split our lights into the different vehicle types. So effectively 83% of that matrix was created to cars. Then we had LGV and a taxi matrix. So we created a taxi matrix for each vehicle type. From that, we were then able to take the cars matrix and split that into cars compliant, cars non-compliant, based on that proportional split that I just showed you. So 86% cars compliant, 14% cars non-compliant. And we're able to also do that with LGVs based on the LGV split of compliant, non-compliant by 2024. But remember, the taxis remained as it was. So this is why we have to pull taxis out of that matrix, because taxis remained compliant. For heavies, it's quite similar, but we kept the heavies compliant matrix, but we split out a non-compliant matrix for heavies for OGV1 and OGV2. But what we can see from that, once you create from a 2 matrix level to a 7 matrix level, is that matrix 1, 2, 3, and 4 are compliant vehicles, and matrix 5, 6, and 7 are non-compliant. And by doing this, this gives you a lot of control over how you model these trips. So just to reiterate, in terms of the matrix level, there was a matrix level for each vehicle type, almost. Matrix level 1, 2, 3, and 4 were our compliant vehicles, and matrix 5, 6, and 7 were our non-compliant vehicles. And this is where you can start developing your restrictions within the traffic model. So if you hang on a sec, I'll just show you this in a live model. This is the Aberdeen model. Malcolm, can you just confirm we can all see this?
Yes, I can see it. It's maybe a little bit
pixelated.
It's not too pixelated, actually. Are you scroll? If you try scrolling in, I'll be able to tell if it's getting stuck. It's just not quite as smooth as it would be.
That's okay.
But yeah,
I don't have too much to show here. So it's really just to show, if I scroll out a second and maybe pull out the satellite just to give a sense of where we are, is usually a good idea in Aberdeen. So this is Aberdeen City Centre. This was the main road through Aberdeen. Anderson Drive was the trunk road. The trunk road is now the bypass that goes round Aberdeen. So that's what I was explaining before about detrunking the city centre. So, and here we have the harbour area. If I zoom back in, We have Union Street routing right through the heart of Aberdeen City Centre. So if I just close that down again, you can get a sense of the scale of the model, included Anderson Drive. So it's a pretty big model, quite a big scale that we've got here. Now I'm scrolling in deliberately till I can stop. Hopefully you'll see some yellow bars there. Before I go into that, actually, I'll open the demand file, and just to confirm what I was shown before in terms of how this is set up, we now have 7 matrix levels we can see across the top. So we've got a cars matrix compliant, lights compliant, taxis compliant, and then a heavies compliant, and then matrix 5, 6, and 7 are our non-compliant matrix levels. So that's how we've set this up. So when I go to the edit network here, if we look at the restrictions, now we've got a lot of restrictions here, mainly for buses and so forth, but what I've done is blackened all these out and just left below an LEZ restriction. So what the LEZ restriction is, effectively, is barring all our non-compliant vehicles. Remember, this doesn't have to be by matrix level, this is barring a vehicle type. So that's how we can easily implement a low emission zone. Hopefully you can see this a little bit in terms of where we've put all our restrictions in the model, throughout the model. But effectively, it's quite easy to then change that boundary and run the model again. So this is just one example of where we put the boundary. If I can scroll in here. So effectively, these links to the north and the west are within the LEZ. If I click on bring in a snapshot here, now just to remind everyone, you can run models from snapshots. So I'm just loading an existing snapshot at 5 o'clock in the afternoon. I'll just wait for that to load. I'll just take a minute. While it's doing that, what I can also do is highlight, go to visualize and look at the vehicle marking. And we select a color here. And what I can do is click on demand sets. So I'll look at the PM peak once that loads up. So I'm looking at the PM peak and I can click on matrix 5, 6, and 7. Go back to snapshots. I'm not sure why it's not loading. Bear with me. Usual story, it doesn't want to do it when you're showing it live. There we go. Just wait a second. Obviously, it's a big model. It takes a minute to load up. No, we're not wanting to. It's not wanting to work. Brilliant. I'm not quite sure why it's not loading. I've got the blue circle of death. There we go. What's the show? Yes, I put the vehicle marking on, so you can see all the red vehicles are effectively our non-compliant vehicles. So if you were to run this model from a snapshot, you see all the red vehicles effectively have to go around the low emission zone. They can't actually route through. I'm not quite sure how this is showing visually, but I think you can just get the gist of what I'm trying to show here is that the non-compliant vehicles don't enter the low emission zone. Of course, like I say, you can change these anywhere. The fantastic thing about Paramics is once you've put these restrictions on, it's the model that dictates and shows you where that non-compliant traffic is going. Anyway, I'll close that down just now because I'm not entirely sure how that's showing, but hopefully you get the gist of how we set up the matrices and the restrictions. As I say, restrictions themselves, very easy to do. It's you have to have the matrix levels and the vehicle type set up in order to do that correctly. The other thing I'd mentioned earlier was to do with car parks. and the assumptions that we had in Paramics, when we had certain zones, this is one example of a boundary as a low emission zone. Within Aberdeen, there was some car parks within the boundary and some car parks outside the boundary. So we had to make an assumption that if you were a non-compliant vehicle and you in your existing trip you were coming into the zone, in reality, what would happen is you would just go to another car park that is outside of the low emission zone. And this is actually a critical element about the boundary, about retaining some kind of access for all vehicle types. That is an important factor. It's not about stopping people getting to the city centre at all. It is an emissions-based exercise, but there was a factor on retaining some level of accessibility for everybody, and this comes down to an economic reason for the city centres, etc. So what we had to do was do some reallocation of origin destination for car parks for non-compliant vehicles. And just to reiterate that, these along the top was different low emission zone options, and these are our key city centre car parks. So you can see under different zones there was different car parks that were inside the boundary and outside the boundary. So there's a bit of matrix work required for each individual option, if you like. So from that, and from how easy it is to change the boundary and run the traffic models, we assessed quite a lot of different LEZ boundary options, quite a few that came from the NLEF process. In actual fact, for Aberdeen, what the model itself helped to develop a final scheme. So it took the best elements of the boundaries that came from the NLEF process. And once we assessed them, we actually were able to develop a hybrid of some of the options, which was the best, met the targets the best. So you're able to quite easily change the boundary and assess it and fine tune around different areas once you get right down into the detail of a low emission zone, even as far as how you would sign it, about vehicle access, how non-compliant vehicles would be able to divert away from the LEZ without having to do a U-turn, etc. So you're constantly changing that boundary, which is quite easy to do within the traffic model. In terms of an assessment of the LEZ, we needed the model, as I showed in the previous slide, we sifted different boundary options that came from the NLEF process, and we identified which boundaries best met the study objectives. This image on the right is a flow plot showing where traffic levels have gone up, traffic levels have gone down. This is pulling outputs from the model and putting them in GIS, which I think is going to be covered in the next workshop next week. But what the model is also able to identify is if other measures are required to help meet the air quality objectives. Is the LEZ alone enough to meet the air quality objectives? But also, is there any other measures required to manage traffic that's just been displaced from the city centre? So the process that we went through was a sort of three-pronged process, a cycle really, whereby we start with the traffic model and assess the operational impact of the schemes, and that helps to sift and develop some schemes. The plan was to then, with a sort of lower number of preferred schemes, was to provide traffic flow and speed data from the traffic model to the air quality model to assess what the air quality impacts were, and that again fed into the final development of the scheme. However, throughout this process, the problem was that our air quality modelling wasn't available. SEPA had issues. Some of you may have been aware of the SEPA were hacked at the turn of the year, and a lot of their data was stolen, so their modelling wasn't available. So we had to very heavily rely on the traffic model outputs to sift and develop the options, but take account of what was the impacts around our air quality exceedance locations. But we were able to sift options through that process, which I'll come on to. In terms of the KPIs and what we use the model for and the outputs from the models, first and foremost was what level of demand were the models able to run at? If what we found was larger low emission zones involved the displacement of a wider volume, a higher volume of non-compliant traffic. And quite often the network wasn't able to manage with that level of network. So we had to reduce the demand down to say, well, you want to implement that scheme, you're only going to be able to run the model at 90% demand. And that's the first and foremost statistic that we pulled out of that model. What level of demand could be achieved? The next key element was what were the traffic flow changes at the exceedance locations? I highlighted these 14 locations earlier where there was known exceedances. So what was happening at those locations when we were running the different low emission zones? We also had to, again, look at how it was aligned to the proposed future network hierarchy in terms of we can look at where traffic flows had increased and decreased and where these appropriate roads for traffic displacement. You've got to remember that traffic displacement is non-compliant vehicles. So what you don't want to be doing is creating a route through a minor road, effectively, a declassified road, and you've got all these old diesel and petrol engine vehicles routing through them. So you have to take cognizance of the hierarchy. A couple of other elements, which is not specifically model related, and I've touched on a minute ago, was the accessibility to the city centre. There needed to be some level of accessibility, even if you had a non-compliant vehicle. Similarly, the larger an LEZ that you have, the more impact it has on residents, people who live within that boundary. Clearly, they would have to upgrade their vehicle if you live within a low emission zone. So the bigger a boundary you go, the more people you're going to impact. So these are all factors when we're assessing the different LEZ boundaries. And also just some sort of global model statistics were quite useful as a comparator between options. So you can look at the global average time taken, average speed, things like that, network-wide traffic queuing. You can look at this on a global level. Without focusing too much on the numbers here, I just wanted to show these two figures when we're looking at the exceedance locations. So these are our 14 exceedance locations, and we had, as an example, of different LEZ boundary options, and we can see where traffic flows had gone down, traffic flows had gone up with each boundary. Some of the boundaries covered these exceedance locations, some of them didn't. They don't necessarily have to cover those areas, but the LEZ has to influence the traffic flow through these areas. So once we gathered that data, we also looked at, this was the survey data from the emissions, the actual emissions from 2019. SEPA were able to provide us with what would be the impact if all buses were compliant. So that does have a big impact, and it has the biggest impact on the routes of where there's most buses. So our starting point from traffic is assuming all the buses are compliant. Here's our remaining exceedances. This is what the LEZ has to address. From that, this is just a banding of likely exceedance results for different options. So what we were able to do was take the change in traffic flow. We were able to see if how that was broken down in terms of number of compliant vehicles, number of non-compliant vehicles, and compare that against the exceedances, assuming all buses were compliant, and really start to develop what impact each of the LEZs had on the NO2 levels, or air quality levels. So as I say, the detail's not important here. It was a comparator of options of how they impact on all our exceedance locations. But what we found was the exceedance analysis suggested that a low emission zone on its own wasn't enough to address all the issues. So without going into too much detail, I'm wary of time here, the city centre master plan includes physical restrictions within the city centre. So we had to develop a package of measures which was a low emission zone and elements of the city centre master plan combined to create this package of measures which will meet all the exceedances. Again, this slide's saying exactly the same thing. There's different projects within the master plan. So we did an extensive amount of testing of different combinations of the low emission zone and different infrastructure projects. And we came up with a package of measures effectively fast tracking elements of the master plan to be part of the low emission zone. Another key aspect that the model was really good at identifying was what other traffic management requirements do you need? Ideally, non-compliant vehicles would route out to Anderson Drive, that what used to be the trunk road, it's now a local distributor. The low emission zone would push that traffic, non-compliant traffic, away from the city centre. But we were getting through this red line some local rerouting around the boundary of the LEZ. So the model was able to show that, and we were able to develop some mitigation measures to push that traffic further out from the city centre. Another key element, and this is a huge part of future modelling when we look at looking at traffic modelling in the future, is alternative futures. This has all come off the back of COVID in terms of we don't quite know what the future is going to look like. So we assessed the low emission zone under different future scenarios. Number one there is what we developed the scheme through, which is your standard local development plan growth, which is high growth. The fleet compliance was an increasing trajectory. So like I showed you before, by 2024, the number of compliant cars would be increasing through time, and we've done the assessment through that. We also looked at what happens if there's an economic downturn, if there's a shrinkage in traffic, but also if there's no change in our fleet compliance. So under that scenario, if there's less compliant vehicles, if there's more non-compliant vehicles, then a low emission zone will be pushing even a higher volume of traffic outside of that zone because there's more non-compliant vehicles. The third scenario that we looked at was called Brave New World. Effectively, it's no growth. It's not to do with an economic downturn, but it's more to do with the change in how people work and travel as a net no growth, but with an increasing trajectory. And this is just to give confidence, certainly to Transport Scotland, of how the low emission zone would work if different futures actually occur. So that it's the level of benefit that you're getting from the low emission zone under different futures. So we've done quite a bit of testing on that as well. Just a couple more slides just to wrap this up. I appreciate I'm going on a wee bit here. The current status of the low emission zones in Aberdeen is we have a package of measures. They're going to committee next week, actually, and there's a public consultation on the scheme proposals through the summer. The idea is that it goes to the Scottish ministers in the autumn with a declaration of scheme, or the start of the scheme, if you like, by May 2022. There's different grace periods for different vehicle types, but effectively it looks like a 2-year grace period, which takes us to 2024. Just finally, just to touch on the points I was made about Paramics, is that obviously, it's a predictive tool. It has this dynamic functionality. When I was saying you put in the rerouting, you put in the restrictions, the traffic modelling shows you where the rerouting is going to happen. And you could move these restrictions around the network and see the different impacts of rerouting. And they're very easy to set up and use, not just for low emission zones, but for a wide range of functions. Similarly, because of that dynamic functionality, you can then identify locations where there's a prediction of potential traffic capacity issues. We found that in Aberdeen through certain routes, and that actually dictated where we extended the low emission zone to cover some routes that just didn't cope with the capacity, and it was resulting in emissions on corridors. So we had to change the LEZ boundary according to the outputs from the model. The model helped decide what the boundary was. Just finally then, the model outputs were very useful to identify areas in the network where the traffic demand has changed. You saw the flow plot differences that I showed earlier on. What mitigating measures are required, where they're required, and what we can do to manage that traffic. We can look at the overall network performance as a comparator between options in terms of average journey time, average speed, etc. But similarly, we can hone right in on specific areas, i.e. our exceedance areas of NO2s. We can hone right in and say what's happening here when we apply the low emission zone. What's the change in flow? What's the vehicle breakdown? And how does that impact? If the flows have gone up and the number of non-compliant vehicles have gone up, clearly you're not addressing the emissions question. So the model was very useful, especially in light of not having the air quality model through the process. It was able to help filter down our options. And that's the end of the slides that I have. I've not been keeping an eye on the questions. Malcolm, do you want to come in at this point?
Yes, that's fine. Callum, I wouldn't have expected you to keep an eye on the chat as well as that. So I've been keeping an eye.
Good.
Thank you very much. That was really interesting, and hopefully that was really helpful and insightful for everyone on the call today. So we do have a few questions for you.
Sure.
One from Dan Seed from Norfolk. Now he's asking how long it took to calibrate the model. I think when he saw the size of the network on the screen was probably what sparked that question.
Yes, yeah. The base model. This is not the first iteration of the Aberdeen base model, but it was developed from scratch. I think you're talking about between, I would say, a 6 and a 9 month process to build these models from scratch, including traffic surveys and getting the data back from those surveys. And building the network is a lot easier than it used to be in Paramics. So that's the quick element. But those who've had to calibrate wide area models will know it's not an exact science in terms of time scale, but the more good data that you have in terms of ANPR and things like that, and to develop your travel patterns, the better, and the more turn count data that you have, then the better chance you've got of being able to pull this into the calibration thresholds quicker.
Yeah. Okay, thank you for that. And I've got another question, but just before I ask, if there are any other questions, please drop them in now. We're going to be on for the next 8 minutes or so, so please don't hesitate if you'd like to ask something. But Joe Appia was asking, he said the LEZ scheme model was built on the base model, splitting and creating the compliance and non-compliance matrices for each vehicle type. Did you have to carry out an ME process and validate the matrices again? No, it's not. It's all done on proportion. It's a proportional split of the existing matrices. So we actually have it was our future year matrices. So all that we're doing is, if you're saying 70% of vehicles were compliant and 30% were non-compliant, it's a global split. It's just taking 30% of that matrix and splitting it out. Otherwise, you're getting yourself into a very, very, very lengthy exercise. Yeah, well, I guess the nature of this is that you can't, once you're starting to look to the future, you have to make assumptions about what that future is going to look like. Yes, but you're also it's where it's quite interesting, Malcolm, is scenario planning does capture some of the variation in that future, and I think this is a real game changer in how we run our future year models. It's not linear. It needs to have a breadth to it. It needs to have, I want to say, a higher and a lower and a medium. That's not necessarily on flow. It could be on economy, etc. So this is a bit of a game changer, and it's come off the back of COVID, to be fair, that we have to look at our future predictions under our future modelling under different scenarios. Yeah, Yeah, absolutely. Yeah. One thing that's quite interesting, I did a couple of polls, Callum, while you were chatting.
Okay.
One of them was just to see whether restrictions, vehicle marking, or snapshots had been, if people had used those features or not. So we've, yeah, it's actually the same for all of them. It looks roughly about 2/3 of people have used them for all three and a third not. So hopefully then for those who haven't used those features, then that'll give them a bit of access to them by seeing them in action today. And the other question I asked was, is low emission zones something which you might be likely to model in the future? And we had 16 votes from that and 10, so 63% do think they're likely to model a low emission zone in the future, which is really interesting. Obviously, it's something then that is going to be popping up elsewhere, as well as in Scotland, which we've come across. Okay, so thanks, Mike, for your comment. It's good. Yes, that's Mike Moore saying he's going to adopt the methodology when he's asked to do something similar. So that's great. And yeah, Mike, get in touch if you need to ask us any questions about that. Yep, and Joe's asking again, how do you assess the capacity of the car parks before and after the scheme implementation with the LEZ zone and outside the LEZ zones?
Yeah, that's a good question. We did look at the capacity. The information that we didn't have was the number of vehicles at the start. So it's really, in this exercise, it's really a proxy. It's really a proxy for, you've got to remember, these are not high volumes of traffic, because the non-compliant traffic is only 13% of all traffic. And it's the non-compliant traffic that was going to a car park. So in Aberdeen, a lot of the car parks weren't anywhere near capacity, but I think you would have to be more careful if you were looking at this exercise where you knew your car parks were at capacity. There's a counter thought to this, in that if you are a compliant vehicle and you know that the non-compliant vehicles can't park within the zone, so there could effectively be a swap going on here, that the non-compliant vehicles are coming out of some car parks and the compliant vehicles are going into those car parks. There could be an exchange, really. So it's something that you would need to keep an eye on. But again, it all comes down to the assumptions that you make at the outset are really critical to how you undertake that assessment. Yeah.
Great, thanks for that, Callum. Okay, I don't think, unless anyone else has a burning question right in the last few minutes, I think hopefully that's covered everything for us. So it's just to say thank you so much for joining us again today. This will be recorded, and so we'll be posting it on YouTube channel and Support Centre if you need to recap on it again. We're going to be back at exactly the same time next week. We're going to be looking at outputs from Paramics Discovery with Neil Kay, another very experienced Paramics user. And then our final session will be all about software news, what we're doing in the product, and what's coming up in the near future. So thanks again for joining us, everyone, and hopefully we'll see many of you next week. Bye.
Thanks for listening, everyone. Thank you.
Thanks, Colin.